All right, everyone, good day. So, this is the third week of our discussion, and for this particular week, we are going to focus on decimals. Okay? Now, I think some of you might already have an idea of what decimals are, but for those who are still confused with it, then we're going to go through some of the basics. Let's begin with looking into real life applications of decimals. Where can you see decimals in real life? Take a look at some of these pictures. What have you noticed with the amount of each liter of gasoline and the gallons that is being purchased? Also, if you try to look at this particular price, you'll see here at the left, you'll see here the unit price. At the right, you'll see here another price. So what have you noticed with all these numbers? I believe right now you already have an idea. You already have mentioned or shared your ideas. But if you try to look at it, you actually see here, or this particular number, for example, is actually composed of a whole number, which in this case is 3, and on the other example is 41. But it seems like we have a decimal point, and after it, there's also another number. So, what does this mean? This is what decimal is, or what decimals are. So basically, if you have a number line, if you talk about any numbers in between two integers or two whole numbers, we actually call it decimals. So in the previous example, you can see that 3 here is an integer, or say a whole number, but then there is a portion of the price that has not received one full whole number. And this number would certainly lie between the integers 3 and 4. That is why in the number line, we can see numbers. We don't only look at numbers that are exactly whole numbers or integers, we also consider numbers that are in between them. And that is what decimals are. In this case, for example, we say that this number can be approximated as 2.4. Zero point 0.4 is the position of the number between 2 and 3. Similarly, if we have a number here, if you are going to estimate it, maybe you can say that this number is between negative 4 and negative 5. Therefore, this is negative 4 point something, closer to negative 5. So we can say this is negative 4.9. So this number, this quantity here that is found between two integers is what we call as the decimals or decimal. Now, if you try to recall, fractions are also quantities that are found in between them. Like for example, if I'd say this particular number, although as a decimal we can say it's half, it's 0.5, we could also express it as 1/2. Now, since decimals and fractions are more or less referring to the same quantity, therefore, there is a way to convert fractions into decimals. Because sometimes, if you go to the market, quantities are expressed as decimals, not so with fractions. Just like what you saw in the prices. So, usually, if you go to the market, you can see prices like $5.3, for example. You don't usually see 5 3/10 of a dollar. So that is not something common. That is why we have to learn, or you have to learn, how to convert fractions into decimals, and of course, decimals into fractions, for you to have a better understanding of the quantities that are present in your surrounding. So let's start with the first skill, converting fractions into decimals. Now, suppose we have 2 and 4/5 of a pizza. All right. So if you talk about two and 4/5. If you talk about two pizzas, this means two whole boxes, 1 and 2. Whereas the 4/5 refer to a pizza which hasn't reached one whole box. So perhaps out of the entire pizza, this is divided into 5 different slices, and one of which was already eaten. That is why we say that we have one box of pizza, which is not equivalent to one whole box. Or we have a box of pizza containing number of slices that is not equivalent to a whole box. So in this example, you can see that one slice has already been taken or eaten. All right, that is why this part is the fractional part. So what if we are going to write this into a decimal? Okay. Now, since we already have here the whole number part, so we don't have to convert this into a decimal because we know that this is a whole number. And thus, what we need to focus more will now be the fractional part 4 over 5. So there are actually two methods of converting fractions into a decimal. The first method is to divide the numerator by the denominator. Again, here, we just have to focus on the fractional part. Alright, so in this case, I will now focus on the 4/5. So divide 4 divide by 5, or divide 4 by 5, thus you will get 0.8. For those of you who find it difficult to do this, I have another video which I'll be sending in Google Space. Click that video if you find it difficult to divide 4 by 5, or if you have forgotten how to divide 4 by 5 to get 0.8. So click that video, watch that. After you have watched that video, then you can continue this particular video. So you can move forward already. So basically 4 divided by 5 is just 0.8. Therefore, the decimal part here is the 0.8. So we can now complete converting 2 and 4/5 into its equivalent decimal, which is just equal to 2.8. And that's how we do the first method. Alright, you can pause this video and take down notes, or you can replay if there are things which you were not able to get clearly. Let's have the second method. So what is the second method? The second method is to make an equivalent fraction with denominator either 10, 100, or 1000, or powers of 10. Take note, when you talk about powers of 10, it's 10 power of 1, which is 10, 10 power of 2, which is 100, and 10 power of 3, which is 1000. Alright, so let's use the same example, but this time, again, we focus on 4/5. Now, 4/5. So the denominator 5, we need to find an equivalent fraction with the denominator of 10, 100, and 1000. And the closest is 10. Okay, so meaning we have to make this into 10. And to make this into 10, we just need to divide this by 2. For us to create an equivalent fraction, whatever we divide in the denominator should also be the same number to be multiplied. Or whatever we multiply rather to the denominator should be the same number to multiply in the numerator. So this will be multiplied by 2, both of them. And thus we get 8 over 10. Now the moment we have written it into an equivalent fraction with the denominator of 10, to convert it into a decimal, recall that all you have to do, by the way, 8 can be written as 8.0. Any number can be written as that number 0.0. To convert this into a decimal, if it's a power of 10, if it's divided by a power of 10, all you have to do is simply to move the decimal point. So if it's divided, the movement of the decimal is towards the left. Now look at the number of zeros. In the 10, there are only 1 0. Therefore, we move this 1 position to the left. I repeat, when we divide by powers of 10, we move the decimal to the left according to the number of zeros. We have 1 0 here. So we move this 1 position to the left, and that is now where the new location of the decimal is. Therefore, 4/5 will just be equal to 0.8, which is just the same with what we got a while ago. This is the second method of converting fractions to decimals. Pause this video and take down notes. Let's have more examples. Let's say 37 over 25. All right. So again, for 37 over 25, you have an option whether, since it's an improper fraction, option to make it into a mixed number, or you can just convert it as an improper fraction. Both will lead you to the same answer. So if we convert it into mixed number, we will have this form or answer here, 1 and 12 over 25. From here, we could already know that this, when converted to a decimal, will have a whole number or integer part which is equal to 1. So we just have to focus to 12 over 25. So first method, remember, divide the numerator by the denominator. Can you pause this video for a while and do it on your own without looking into the answer? After, check if your answer is correct. Alright? So divide the numerator, then we will get 0.48. So this is equal to 1.48 then. Now how about for method 2? So for method 2, we make an equivalent fraction. We focus on 12 over 25. So all we have to do is just to make this into a power of 10. So we cannot anymore make this into a power of, we cannot anymore make the denominator into 10, but the next closer to it is 100. So let's try to see if we can make 25 into 100. Make an equivalent fraction by multiplying 25 by a certain amount, and that amount is 4. So we multiply both numerator and denominator by 4, thus we get 48 over 100. So from here, when we divide it by a power of 10, remember that we just have to move the decimals. So 48 here is equal to 48.0. Since we divide by 10 or powers of 10, move the decimal to the left. In this case, we have two zeros. Therefore, this decimal should be moved to the left twice as well. So 1, 2, and this is now the new location of the decimal. Therefore, 48 over 100 is 0.48. So in this case, the value would now be 1.48. Alright, pause this video, take down notes, or you may replay. You could also do it directly without converting it into a mixed number. So by means of method 1, so 37 divided by 25, by doing this, you will get 1.48. Now method 2, it's the same thing. So it's the denominator is 25. We know already that we multiply both numerator and denominator by 4. So we get 148 over 100. Again, 148 is just equal to 148.0. Now, when we divide by powers of 10, we move the decimal to the left. We have two zeros for 100, so we move it two locations to the left as well. 1, 2. Alright? And thus you get 1.48. See, the answers are the same. Alright? Now, how about if you have 11 over 3? So for 11 over 3, again, you have two options. We can write this as a mixed number. From the mixed number, we get the whole number part if there is. So this is 3 point something. We just focus on 2/3. So 2 divided by 3, that's 0.666. So if you notice, it's repeating. And the decimal part will just simply repeat. So all you have to do is to find the repeating portion or the portion of the decimal which repeats. So just copy it once. You don't have to repeat it. Again, just copy the portion which repeats and then put a bar on top. Alright? So we now know that the decimal is 0.6 with a bar on top. It means this value 6 just simply repeats. So the answer is 3.6 with a bar on top. So the bar on top should only be written on the decimal part which repeats, okay, or the portion which is repeatedly appearing, or sometimes we call it recurring. Alright, now in this case, we cannot apply method number 2 because there's no way for us to write or to multiply a number to 3 to make it powers of 10. So since we cannot do that, therefore we can only apply method 1 for this. Last example, what if we have 1 over 11? So again here, we don't have a whole number part because it's proper fraction. So we assume the whole number part is 0. So 0 point something. So applying method 1, we divide 1 by 11, thus we get 0.909090. So in this case, the 0 and the 9, the first two digits after the decimal point 0 and the 9 is repeating. So we just copy it once and put a bar on top. Therefore, the decimal equivalent of this is 0.09, and the 0 and the 9 will have a bar on top. Okay? Again, there's no way for us to write an equivalent fraction for a denominator of 11, making it into powers of 10. So we cannot apply method number 2. So method number 2 is only applicable if there is a way to write the denominator into a powers of 10. If it's not possible, then we can just do method number 1. Okay, pause this video, take down notes. This time, let's now go to the second part, which is decimals into fractions. So how do we convert decimals into fractions? This is an easy discussion, so you don't have to worry about it. But before that, I'd like you to look into first three different kinds of decimals. For the one on top, if you try to look at it, the decimals actually stops at a certain point, meaning there's a specific number of decimals or numbers, or there are specific numbers after the decimal point. Because your decimals stop at certain points, we call the decimals in the topmost portion as terminating decimals, from the word terminate, meaning it ends. It ends at a certain part. However, if you notice in the second one, the one in the middle, just like our previous example, this number repeats, meaning it never stops, it repeats. So we call these as repeating or recurring decimals. These are decimals that repeats and never stops. However, there are also decimals that are not repeating, just like the one you see below. They are not repeating, yet they're also not terminating, meaning they don't end and they don't repeat. So we call these decimals as non-terminating and also non-repeating. So you expect to see three different kinds of decimals. For this example, for this discussion, we will focus on terminating decimals. All right, let's have some examples. How do we convert terminating decimals into fractions? Again, this is an easy discussion. So suppose we have a decimal 7.36. Now take note in this decimal, this one is the whole number part. Well, this one is the part which is less than a whole number or less than an integer. Okay? So since we have a whole number part, so we now know that the fraction would also contain a whole number part. So we have 7. So what we need to focus only is the decimal part, which is 0.36, because we already know that there is 7, which is a whole number. So we don't have to convert it into a fraction. Okay, so only the 0.36 will be converted into a fraction. How do we do that? All you have to do, class, is simply to count how many decimal numbers are there, or how many digits are there after the decimal point. In this case, it's 2. Now, this will simply be equal to 36 over 100, meaning 36 over powers of 10, and the number of zeros would depend on the number of digits to the right of the decimal. So if there are 2 digits here, therefore we divide by 100. If there's 1, we divide it by 10. There's only 1 0. If there's 3, we divide by a power of 10 with 3 zeros, and that is 1,000. So again, it depends on the number of digits. So 36 over 100, simplify these, divide both by a power of 4, by 4. So this now becomes 9 over 25. Therefore, your fraction is 7 and 9 over 25. Or you could also write this as a mixed number, 184 over 25. And that's how easy it is. Alright, pause this video, take down notes. Another example is 0.4. So in this case, we can see that there is no whole number part. So this must be a proper fraction. So we can just simply focus on the decimal part, 0.4. So how many digits can you see after the decimal place? There's only 1. Therefore, this will be equal to 4 without the decimal over a power of 10 with 1 0, and that's 10. Reduce it, we got 2/5, and that's done. Alright? And lastly, so this we have whole number part, this is the decimal part. So we know that the fraction will be 1 and a certain fraction. Okay? So 1 and a certain fraction. So the fractional part will be this. So count the number of the numbers after the decimal point. There are 3 numbers. Therefore, this will just be 255 over power of 10 with 3 zeros, which is 8,000. Reduce the lowest term, divide both numerator and denominator by their HCF, which is 5. Thus we will get 51 over 200. So the fraction now is 151 over 200. Or converting it into mixed number, that's 251 over 200. Alright, and that's how easy it is. Pause this video please and take down notes. This time, we now have the last portion, reading decimals properly. So how do you read decimals properly? Suppose we have this one. Most of the students or people would read this the first one as 1.255, which is actually fine. But this is the informal way. So how do you formally and properly read this decimal? Maybe some of you knows this already, but for those who don't, this will be a discussion for you. Now, before we can read this, uh, we can write this one normally, just like a normal number. We can just say this is actually equal to 1, and then the decimal, we just say and 255. But the question is, what sets apart the decimal part and the integer or the whole number part? So if we just write it this way, then there's no difference. Okay, there must be some sort of a difference between the whole number and the decimal. And that's actually given by the decimal place value. So I'd like you to focus on the decimal portion. So for the decimal, the place value starts with tens. And if you try to look at it, it ends with TH and S. This alone already makes it different from the whole number. So every place value in the decimal ends with THS. Another difference is in the whole number it starts with ones, then tens, then hundreds. In the decimal, there's no ones. We start with tens. So the first digit in the decimal part already is tens. Okay? So meaning the first one is tens, then hundreds, then thousands. So in this case, we go back to this. This is now 1 and 255. Since there are 3, if this was a whole number, we read this as 100, 200. But then in the decimal, this is thousands. So we say 1 and 255 thousands. And this is the proper way of reading decimals. Can you read the second one? Try to, if you could remember. All right, this is 7, and then the decimal, and 36. Now, since there are 2 digits here, this is tens, this is hundreds. So we read this as 7 and 36 hundreds. How about the last one? So the last one is, we have 0 here, so there's no need to write 0 and, we just go directly to the decimal. So the decimal part is 4. There's only 1 digit here, therefore, this is in the place value tens. So meaning 4 tenths. And that's how easy it is to read decimals properly. All right? So for your activity, I'd like you to work on the worksheets provided, write your answers in the notebook. The activity comes in 3 levels, red, yellow, and green. It will be further explained by me in class. Thank you, and you may now proceed.